Products of electrolysis. Products of electrolysis depend upon the nature of the electrolyte, or it can also be said on the nature of the material being electrolyzed. It also depends upon the type of electrode, that is whether the electrode is inert or reactive. If the electrode is inert, that is platinum electrode or gold, then these electrodes do not participate in the chemical reaction. But a reactive electrode will participate in the electrode reaction. So if electrode is inert like platinum or gold, it does not participate in the chemical reaction and acts only as source or sink for electrons. On the other hand, if electrode is reactive, it participates in the electrode reaction, and product of electrolysis may be different for reactive and inert electrodes. Then product of electrolysis also depends upon the electrode potential values of the species present in the electrolytic cell. So product of electrolysis depends on the different oxidizing and reducing species present in the electrolytic cell and their standard electrode potentials. Now some electrochemical processes, they are feasible, but they are so slow kinetically that at lower voltages these do not seem to take place, and extra potential, which is also known as over potential, has to be applied, which makes such processes more difficult to occur. Now consider the electrolysis of molten NaCl. Now for molten NaCl, NaCl will ionize to give Na plus and Cl minus ions. Na plus ions go to the cathode, accept one electron and change into neutral sodium atoms. On the other hand, chloride ion, this is the anion, it goes to the anode, loses electron and is oxidized at the anode. So this is the product formed when molten NaCl is used as electrolyte. Chlorine gas at anode and sodium at cathode. But if aqueous solution of NaCl is used, then NaCl will ionize to form Na plus and Cl minus ion, and water will also ionize to form H plus and OH minus ion. Now both Na plus and H plus ions will go to the cathode. Now comparing their reduction potential values. Reduction potential value for sodium ion is minus 2.71 and for H plus ion is 0. Therefore reduction potential value of sodium ion is less than H plus ion. Therefore H plus ion will be reduced at the cathode, giving hydrogen gas. So H plus ion accepts electron at the cathode and product at the cathode is hydrogen gas. Now this H plus ion is produced by the dissociation of H2O. Therefore this reaction can also be written as H2O plus electron forming half H2 and OH minus ion. This is the reaction at the cathode. Now at the anode, what will be the reaction? At the anode, both chloride ion and OH minus ion go to the anode. Now chloride ion, aqueous, it will undergo oxidation, it will form chlorine gas. Here in chloride ion, the oxidation state of chlorine is -1 and in chlorine it is 0. So it is undergoing oxidation, losing one electron. For OH minus ion, now since OH minus ion is coming from H2O, therefore it can be written as H2O is getting oxidized to O2 plus H plus, and balancing the equation, this can be written as 2H2O 4H plus 4 electron. Now here oxidation state of oxygen in H2O is -2 and in O2 it is 0. So this is oxidation reaction. Now in this case See, equation 2.36 is for the oxidation of chloride ion to chlorine, and equation 2.37 is for the oxidation of H2O to oxygen. Now, reduction potential value for chloride ion is greater in comparison to water. Reduction potential of chloride ion is greater than reduction potential of water. Or it can be said that oxidation potential of chloride ion is less than oxidation potential of water. So which one will get oxidized at the anode? From the reduction potential values, H2O should get oxidized at the anode. But again, this process is kinetically slow. So extra potential has to be applied to carry out this oxidation reaction, which would lead to overpotential. So due to overpotential, this reaction is not preferred, and instead chloride ion is getting oxidized at the anode. Chloride ion gets oxidized at anode to give chlorine gas. So the product which is formed at cathode is hydrogen gas, and product formed at anode is chlorine gas. And what is left behind in the solution? In the solution, Na plus and OH minus ions are left. The reaction at anode with lower value of E naught is preferred, and therefore water should get oxidized in preference to chloride ion. However, on account of overpotential of oxygen, reaction 2.36 is preferred, means oxidation of chloride ion is preferred. Thus, the net reaction may be summarized as NaCl breaking into Na plus and Cl minus ion. At the cathode, reduction of water, hydrogen gas is produced, OH minus ion goes in the solution. At the anode, chloride ion is oxidized to give chlorine gas. So the net reaction is NaCl plus H2O forming Na plus OH minus, and hydrogen and chlorine gases are formed. Hydrogen is formed at the cathode, this gas is formed at the cathode, and chlorine gas is formed at the anode. And Na plus ion from NaCl is left in solution, and OH minus ion from H2O is left in solution. The standard electrode potentials are replaced by electrode potentials given by Nernst equation to take into account the concentration effects. During the electrolysis of sulfuric acid, the following processes are possible at anode, means H2O getting oxidized to oxygen, 4H plus ions are formed plus 4 electron, and SO4 2 minus ions changing into S2O8 aqueous and giving 2 electrons. For dilute sulfuric acid, reaction 2.38 is preferred. For dilute sulfuric acid, oxidation of H2O will take place, giving oxygen gas at the anode. Whereas at higher concentrations of sulfuric acid, reaction 2.39 is preferred, that is SO4 2 minus ion are oxidized to give S2O8 2 minus ions.